Okay, I had a question asking about how I am able to quickly graph in vertex form. So, vertex form remembers a times x minus h squared plus k. And hk represents the vertex of the quadratic. So, no matter what a is, the vertex will always be h comma k. So, for instance, let's start with, let's say, x minus 2 squared plus 1. So I know this is just a transformation of the parent function y equals x squared. So it's going to take that parent function, it's going to go over 2 and up 1. So right 2 and up 1. And it's also going to take all of the other points. So if I think about, I'm going to graph it really quick for you. I hope that you remember from Algebra 1. Let's do it in a slightly different color. So 2, 3, 4. Y equals x squared, if you just plot those points, is the parabola that looks like this. So I'm essentially taking all of those points and I'm shifting them to the right 2 and up 1. So I'm going to erase that now so that you can see what I'm doing. So there was a point here, so I could go right 2 and up 1 and so forth. But I know that the quadratic function comes from going over some distance. Well, I don't need to put a point there. Going over some distance and then going up that distance squared. So in this case, if I go over 1, I would go up 1 squared. If I go over 2, I would go up 2 squared from the vertex. So over 2, 1, 2, 3, 4. And that's where those points are coming from because they're coming from the parent function. They're coming from y equals x squared. So if I go left 1, I would go up negative 1 squared. If I go left 2, I would be going up negative 2 squared. And that gives me this function right here. Well, the question that I actually was asked was, well, how can you graph if a is not just 1? What if I switch a's value? So first, I'm going to make a positive number. Let's say 2. Y equals 2 times x minus 2 squared plus 1. Remember, a tells us a vertical stretch. So I'm still going to go over 1 to find a point, and I could use any number I wanted, but I'm choosing to go over 1. And I know I typically go up 1 squared, but now I'm stretching that. I'm pulling it taller by a factor of 2. So 1 squared times 2 is 2. So now if I go back and let's say I go over 2, typically I would go up 2 squared. However, if I put this 2 right here, now I'm going to stretch 2 squared by a factor of 2. Well, 2 squared is 4 times 2, so now I'm going to be going up 1, 2, 3, 4, 5, 6, 7, 8. And it should make sense that as I'm stretching it from vertically, so that's almost like I'm holding right here and I'm holding right here on the ends of my y-axis, and I'm pulling all of that entire graph from the ends of the y-axis to stretch it vertically. It should make sense. Whoops. I was counting in 1, 2, 3, 4, 5, 6, 7, 8. It should make sense that it is getting skinnier. And if you notice, it's symmetric with respect to the axis of symmetry still. And so that's making that graph skinnier. Now, what happens if it changes to negative? So I'm going to make it now the same vertex. I don't want quite that same color. Y equals, let's say, negative 1/2 x minus 2 squared plus 1. So same vertex, but now that negative 1/2 flips it over the x-axis. So it's going to be opening down instead of up. But I do everything else the same. So I would go over 1, and I typically would go up 1, or 1 squared. But because it's negative, I'm going down, but this is also times by 1/2, which is going to shrink it. So if I go over 2, I typically would go up 4. Now I'm going to go down 4, but then I'm going to compress that by a factor of 1/2, which will give me a point right there. If I go to the left 2, I would typically go down 4, but because I'm compressing that by a factor of 2, or excuse me, compressing it by a factor of 1/2, it will end up right there. And if you notice, the quadratic function is getting wider. And if you think about holding the ends of the y-axis and smushing your hands together, that's essentially what's happening to that function. I'm making the motions with my hands right now, you just can't see. But if this weighted graph does not work for you and you want to go back to using tables, tables are also an option. You can make your parent function, which is y equals x squared. You have the points -2, -1, 0, 1, and 2. The y values would be those numbers squared. And then we can make a transformation table. So we have x plus 2, and then we have -1/2 y plus 1. In Algebra 1, this is probably how you typically saw it. So we transform these points. So I take each of my x values and add 2. -2 plus 2 is 0. 1, 2, 3, and 4. And then multiply by -1/2 and add 1. 4 times -1/2 is -2. Plus 1 is -1. And if you look back at the graph, that's what I just had graphed. So -1/2 plus 1, 1/2. Again, that's what was on my graph. 0 times -1/2 plus 1, and then keep going to fill in the table. If you have more questions, please email. Have a great day.